This is part 2 of simplifying complex fractions. We are starting on example number 3. And once again, we have 2 methods for solving these. And on this particular method, what we're going to do is we're going to add the top of the fractions together. We're going to add the bottom of the fractions, or subtract the bottom of the fractions. And then we'll finish by dividing. So I'll use my space a little bit better. But let's take 3 divided by y plus 4 divided by x. And we're going to find the common denominator. Common denominator can be determined by taking y times x. That's all we can do. Y is different than x. The only thing we can do is multiply them together. If you prefer to write x times y, nothing wrong with that. It doesn't matter if you write y times x. Commutative property, we can change the order without changing the value. Well, what did we put into this denominator that wasn't there before? We put in an x. This is going to be 3x. Ask yourself the same kind of question over there to the right. What did we put into that denominator that wasn't there before? It's the y. And in the numerator, the top of the overall big fraction there, the only thing that we can do now is say that this is 3x plus 4y divided by yx. Don't cancel anything out. We cannot factor anything in that problem, so we cannot cancel anything in that problem. And all that we've done so far is we've done the top of that fraction. I'll make this line a little bit darker. We've done the top part, the numerator of the overall fraction. Complex fractions meaning that we have fractions within a fraction. And we only want to end up with one. So now as we take a look at that, we've dealt with the top, so let's deal with the bottom, which is 9 over y squared minus 16 over x squared. Once again, we need to find the common denominator. And y squared is different from x squared. The only thing we can do is we can multiply the two together. We'll get y squared, x squared. And just like before, if you want to write it in alphabetical order, that's traditional. It doesn't make any difference. We're subtracting. What did we put into our left-hand fraction into the denominator that wasn't there before? Put the x squared. And what did we put into our right-hand function in the denominator that wasn't there before? We'll put the y squared. Don't cancel anything out. I know that within the fraction we have an x squared over an x squared, or a y squared over y squared. We're using the fancy form of 1 with our fractions. And if we cancel it out, we don't have common denominator. So the only thing that we can do in this case is we can combine. We have 9x squared minus 16y squared divided by y squared, x squared. But as we take a quick look at that, is there anything more that we can do with that fraction? And what we can do is we can factor that numerator because it's the difference between two squares. So this is 3x. The square root of 9 is 3. The square root of x squared is x. Square root of 16 is 4. Square root of y squared is y. Difference between two squares, different signs. And we still have our y squared, x squared. Well, now, we've simplified the top of the fraction, we've simplified the bottom of the fraction, and now we need to divide. So I'm going to write it again. And I think I can squeeze it in. I hope I'm not messing you up too much. 3x plus 4y over yx. That was the top of the fraction. Here in black is the bottom of the fraction. And I'm going to go old school with the division. Well, when dividing, don't ask why, flip the second one and multiply. So nothing's going to happen with this 3x plus 4y over yx. But we are going to multiply now. And we've got y squared x squared. And then it's 3x minus 4y. 3x plus 4y. One more time. When dividing, don't ask why. Flip the second one and multiply. I should have written that fraction in black, but oh well. And then we ask ourselves, do we have anything exactly the same in the top and in the bottom? Well, we have a 3x plus 4y. And there actually is a little bit more, but some of you start at this point. You cancel that part out, and now we have y squared x squared over yx times 3x minus 4y. Well, we can simplify. It's not exactly the same in the top and the bottom, but we can simplify that. And we can simplify here also. Remember when we divide these monomials, what happens is we divide and subtract. So this is y to the 2 minus 1, and it's going to end up in the top of the fraction because 2 is bigger than 1. And it's going to be the same computation for x. It's going to be x to the 2 minus 1. And then we've got 3x minus 4y. And finally, what that gives us is 2 minus 1 is y. 2 minus 1 is 1. Sorry. 2 minus 1 is 1, so it's y to the first. 2 minus 1 is 1, x to the first, divided by 3x minus 4y. And again, do not cancel. So again, looking at two different methods for now. And in this particular problem, what I'd like to do is find the least common denominator between all the minor fractions. So first of all, I'm going to make this fraction a little bit bigger so I can write it in a little bit more. What this is 1 over 1. And this is 1 over 1. And if you like the adding method, add the top together, add the bottom together, and then divide, that's fine. Just want to show you one more here to give you an alternative. What we do with the least common denominator, we need to find the least common denominator, is we look at each individual term in this problem. 1 over 1, so our denominator is 1. 7 over x minus 2, our denominator is x minus 2. 1 over 1, there's another denominator of 1. 3 over x plus 2, x plus 2 is the denominator. We want to find the common denominator of all of those. Between 1, x minus 2, 1, and x plus 2. Well, luckily, there's some 1s in there. And the only thing that we can do between x minus 2 and x plus 2 is we can multiply those together. Again, if you don't like this method, we'll go back to the addition method in a minute. But once we determine what the least common denominator is, we're going to take x minus 2 times x plus 2 times 1. Then we're going to take, and actually I can write that over 1. Then we're going to take x minus 2 times x plus 2 times 7 over x minus 2. We multiply each individual term by the least common denominator. We still have to do that in the bottom here, the denominator of the overall fraction, and we have x minus 2 times x plus 2 times 1 again. And then we have x minus 2 times x plus 2 times 3 over x plus 2. We multiply every individual fraction by the least common denominator of all of them together. When we do this, then we're going to go back and say, eventually, do we have anything exactly the same in the top and the bottom? But on this first one, we took x minus 2 times x plus 2 times 1. Well, anything times 1 is just going to be that anything. So we're going to be left with x minus 2 times x plus 2. Don't really need to write the 1 in the denominator. We're trying to get the fractions out. But when we look at our next term here, we've got x minus 2 times x plus 2 times 7 over x minus 2. Do we have anything exactly the same in the top and in the bottom? We've got an x minus 2. So we're going to cancel that out, and we're going to be left with x plus 2 times 7. And you could write the 7 in front. It's not going to make any difference. We're going to have to distribute eventually. In the denominator, we have x minus 2 times x plus 2 times 1. Once again, anything times 1 is that anything, which is the x minus 2 times the x plus 2. And to the very, very far right of the screen, we've got x minus 2 times x plus 2 times 3 over x plus 2. Do we have anything exactly the same in the top and in the bottom? We've got an x plus 2. And we're left with x minus 2 times 3. Don't cancel anything out here. You can't cancel out these x minus 2, x plus 2 in black. They don't cancel out. And what we do need to do is we need to take this fraction now that's taking up most of the board, and we're going to FOIL. Here, and here, and here, and here. So we get x squared plus 2x minus 2x minus 4. First, outer, inner, last. It's distributive property. In our next, distribute the 7, and we get plus 7x plus 14. And we did have the same exact thing on the top and in the bottom, but we're adding. That's the difference. If we're multiplying, we can cancel it out, but we're adding here, so we can't cancel it out. But if we FOIL in the denominator, we get x squared plus 2x minus 2x minus 4. And to the far right, we're going to distribute plus 3x minus 6. So we look at this, and we need to combine like terms. But the nice part is we've got 2x minus 2x. And when we simplify up there, there's nothing like with the x squared. 2x's cancel out. Then we have plus 7x And negative 4 plus 14 is plus 10. We need to combine like terms in the bottom, in the denominator. But we still have plus 2x and minus 2x, which cancel out. And then we get x squared plus 3x minus 10. Are we done? And you should be shaking your head no. Because now, after all of that, and it seemed like it might be shorter, and it hasn't been, but after all of that, we need a factor. And see if we have anything exactly the same in the top and in the bottom. So when we look at this, we got x squared plus 10. Factors of 10 that combine to be 7? 2 and 5. Plus 2x plus 5x. And here's our first group, and here's our second group. And we end up with x times x plus 2 plus 5 times x plus 2. And luckily enough, we have an x plus 2 in both groups. So we end up with x plus 2 times x plus 5. So there's the numerator, the top of the fraction. When we look at the denominator, we've got x squared plus 3x minus 10. Well, is there anything that combines to be 3?
2. Negative 2.
Negative 2 plus 5. And once again, we group. Here's a group, and here's a group. And then we're going to factor. So we take out an x. We're left with x minus 2. Over here, greatest common factor in the second group is 5. Then we've got x minus 2. And once again, x minus 2 here, x minus 2 here, get x minus 2 times x plus 5. So we're darn close to finishing now, but we better write it back in the proper format. The black two binomials, x plus 2 and x plus 5, came from the numerator of our problem. The red values came from the denominator of our problem. And the last question is, do we have anything exactly the same in the top and in the bottom? We have an x plus 5. So when we finally finish this problem, we end up with x plus 2 divided by x minus 2. Again, no, you can't cancel anything. We can't factor that anymore. We've done our canceling. So we're going to finish these remaining two methods with our original method, which is we're going to add the fractions together. In this case, in the numerator, we're going to subtract them. Luckily, on this particular denominator, we don't need to do anything to combine them. It's already combined into 1, and then we'll divide. But we simplify the top, we simplify the bottom, and then we divide. So well, let me write it down. We have 1 divided by x minus 1 minus 1 divided by x. What's the common denominator? And even if you aren't going to answer me, at least think it in your head. What do you have to do to get that to common denominator? Well, what we have to do is we have to take x minus 1 and multiply by x. And I actually am going to write it as x times x minus 1. That's all we can do. This one's got something to the far left. That one has something subtracted. The x is a standalone. That's all we can do, is multiply these two together. And we're subtracting. I'll put that in a different color just to highlight that fact. And then we ask ourselves, what did we put into the denominator that wasn't in there already? Well, in this left-hand fraction, we put in there an x. In the right-hand fraction, we put in an x minus 1. Again, don't cancel anything out. We're multiplying by a fancy form of 1, so we're gonna have something that's the same on the top and the bottom. Now, one of the reasons why I highlight the minus in red is I'm going to write an extra step here. 1 times x is x, and then put that back in red, minus 1 times x minus 1. We have to be really, really careful when we're subtracting, because this red negative impacts both values in the numerator of that fraction to the right. Negative 1 gets distributed here. Negative 1 gets distributed here. That's where people tend to make their mistake, is they forget to distribute the negative. So we have x minus 1x plus 1. Because negative times negative is positive 1, divided by x times x minus 1. And then I know I wrote that 1 on the second x, but it's really 1x minus 1x. When we simplify this, simply leaves us with 1 over x times x minus 1. So we simplified the top. As we take a quick look here, I'm going to write this, and then we're going to go old school here, divided by. What's in the bottom of our fraction? Well, we don't have to add anything or subtract anything together, so we can start using it. It's 1 divided by x squared. I need to look at it again. Minus x. We can do one thing to that denominator, and I should have done it sooner. We can factor it. But this isn't going to change. It's 1 over x times x minus 1. Over here, if we factor the greatest common factor, we've got x, so we get x minus 1. Well, do we need to even flip and multiply on this one? No, because we've got something divided by the same something, and what does something divided by the same something equal? Equals 1. I'll show more work if I need to. So one last time. We're going to add the numerator, the top of this fraction. We don't have to do that to the denominator, but we do need to remember to factor it, because it does need to be factored, and then we'll divide. So we have x divided by x plus 6 minus 1 over x plus 2. And the nice part about this method is that it gives us more practice with adding and subtracting, and I think that we need more practice with adding and subtracting. So as we take a look at this, the common denominator is going to be x plus 6 times x plus 2. We are going to subtract. What our common denominator? Is there. Then we ask ourselves, do we have something in the denominator now that wasn't in there before? And we do. We have the x plus 2 over here to the left. And on the right side, the 1 stays there, but what we put into the denominator that wasn't there before was the x plus 6. And I know that sometimes it's a pain to write the next step. And I don't care if you write the next step. But you need to be really conscious of the fact that this is a minus. Because people make that little mistake and then it seems like such a small thing and it causes big mistakes, is what I'm trying to say. So what we have here is we have x times x plus 2 minus 1 times x plus 6 all divided by x plus 6 times x plus 2. And so far all that we've done is we've been dealing with the top of our fraction when we distribute. We get x squared plus 2x. But over here is the kicker. It's negative 1 times x, and that's not what people miss. It's the negative 1 times the positive 6, which is negative 6. And we have x plus 6 times x plus 2 still in our denominator. We combine like terms. And we have x squared plus x minus 6 over x plus 6 times x plus 2. What the heck? X plus 2. The question is, do you think we can factor that top numerator? And it looks like we can. So as I come up to the side here, maybe not. I'll go underneath still. We've got x squared and we've got minus 6. What combines to be 1? 2 and 3. Which one's positive? It's actually the 3. But when we factor, we've got x times x minus 2. We have 3 times x minus 2. And now, we have x minus 2 times x plus 3. As we take a quick look there, did that help us at all? No. But we can put it back in there. So we've got x minus 2 times x plus 3. In our denominator, we have x plus 6 and x plus 2. And eventually here, what we're going to do is we're going to divide. So I'm going to scroll back up at the very top here and see if I've got enough space. So what we have in the numerator of our denominator, confuse it. So we're looking at the bottom of this big fraction, and we're looking at x squared minus 4. Well, we can factor x squared minus 4 into x minus 2 times x plus 2. Square root of x squared is x. Square root of 4 is 2. But we have to do a little bit more work on x squared plus 8x plus 12. So what we're looking for is we're looking for factors of 12 that combine to be 8. Do we have any? Yes. Plus 2x and plus 6x. Stay with me, we got time. And when we group here, we've got x, so x plus 2, plus 6 times x plus 2, which ultimately means that we have x plus 2 times x plus 6, now. I highly recommend that you follow my rule. It might be a little goofy, but when dividing donuts y, flip the second one to multiply. I recommend that you write that step. I think that some of you missed problems on the quiz because you didn't flip. But when dividing donuts y, flip the second one to multiply. So the green isn't going to change. And then, here are blue, or black, sorry, we're going to multiply, because we're flipping it. We've got x plus 2 times x plus 6, and then we have x minus 2, and x plus 2. So to finish, do we have anything exactly the same in the top and in the bottom? We've got an x plus 2. We have an x minus 2. We've got an x plus 6. And then we're left with our simplified version of x plus 3 and x plus 2.